So this problem comes from 6.3. It's question number 3. It says find the Maclaurin series of x to the 5th e to the 8x. So in problems like this, you're going to start by writing the Maclaurin series for one of the known functions. So the Maclaurin series for, let me grab my pen, e to the x is equal to the infinite sum from n from 0 to infinity of x to the n over n factorial. And now we'll just need to modify this sum. So we want to modify it to match our function. And so in this one here, we have e to the 8x. So then what I'm going to do is replace the x here with 8x. So that means I'll replace the x here with 8x. And it'll be 8x to the n power. And now I still have this x to the 5th. So now we're still missing this x to the 5th. So I'm going to put an x to the 5th here. And I'll also put an x to the 5th here. And now I just need to do some algebra. And using the exponent rules and multiplying this x to the 5th, we will get x to the 5th. And then my exponent rules, this n applies to both the 8 and the x. And in the denominator, I have n factorial. So now I have some like bases there, the like bases of x. And so when you have like bases and they're multiplied together, it's the same as saying rewrite the base and add the exponents. And then in the denominator, this will still be n factorial. And so now I have written this. Now I have found the Maclaurin series of x to the 5th e to the 8x. So this is my answer here.